Hello, today I'm going to be talking about section 4.7, which is the quadratic formula. And the learning target for today is that to solve quadratic equations using the quadratic formula. Now, the previous two lessons we've been talking about factoring quadratic equations in order to split up the middle term and find two solutions, or one or none, to a quadratic equation. And the last one was completing the square, which is another method to use when solving quadratic equations. And the third and final method, which you probably touched a little bit on AG2, is to use what's called the quadratic formula by plugging in certain pieces into a formula and solving for x. So let's get started. Okay, so let's assume that our general quadratic equation is in the form of ax squared plus bx plus c, and it is equal to 0. As long as a is not 0, this is a valid quadratic equation. If this is true, then we are able to use the quadratic formula to solve for x. Negative b plus or minus the square root of b squared minus 4ac, all of that's underneath the radical, and everything is being divided by 2a. Taking each of your parts of your a, b, and c from your quadratic equation, a, b, and c. Plug everything in, combine everything underneath the radical, and reduce down to 1, 2, or even 0 solutions will give you your answer. Let's go through one example. Okay, let's say our quadratic equation is 2x squared minus x equals 4. Now, the very first thing before we can plug it into our formula is to move this 4 onto the other side and have it set equal to 0. So I'm going to subtract 4 on both sides of my equation. Okay, now I have it in the general form of my quadratic equation. Ax squared plus bx plus c is equal to 0. So that means my a is 2, my b is a negative 1, and my c is a negative 4. Using these three parts, I can plug them into my quadratic formula, which is x equals negative b, which is the opposite of a negative 1, plus or minus the square root of b squared minus 4 times a times c. And this is all being divided by 2 times a. Okay, let's reduce everything that's underneath the radical first. Negative 1 squared is a positive 1. And a negative 4 times 2 times a negative 4. These two give me negative 8 times a negative 4 gives me a positive 33, sorry. And in the denominator of my fraction, 2 times 2 gives me a 4. 1 plus 33 underneath the radical. Actually, I'm sorry, this is a 32. Four times 2 times 4 is 32. Then when we add the 1, we get our 33. Okay, and to be quite honest, I am perfectly okay with you leaving your solution like this. If you want to take the square root of 33 and split it up by adding 1 dividing by 4, then subtracting 1 dividing by 4, this is okay. But this tells me you have two solutions. One of them is 1 plus the square root of 33 divided by 4, and the other one is 1 minus the square root of 33 divided by 4. But if you get a radical that you cannot take the square root of and get a whole number, which in this case 33 does not give us a whole number, then you can leave this as your solution. One last thing I wanted to talk about is that there is something inside our quadratic formula that we can use from the very beginning to tell us how many solutions we have. And that is what's called the discriminant. Inside our quadratic formula, the discriminant is everything that is underneath the radical. And everything that is underneath the radical is just b squared minus 4ac. If we plug in all of our values into this discriminant, and we get an answer that is greater than 0 or positive number, then that means we have two real solutions. If we get a number that equals 0, we have one real solution. And for any answers that we get that are less than 0, we have no solutions. The reason why we would have no solutions if it's less than 0, because you cannot take the square root of a negative number. That does not give us a real answer. So let's go back to our original example and see if we can prove that we get two answers in our discriminant. Remember, our a value was 2, our b value was -1, and our c value was -4. I'm going to plug everything into my discriminant, which is -1 squared minus 4 times 2 times -4. -1 squared is 1. -4 times 2 times -4 is a positive 32. And 1 plus 32 is a positive 33. Since this is a positive number, we can therefore claim that this quadratic equation will give us two real solutions.